I have a question from Bikas Kumar Day, and it is on Faraday's law, and the question is, according to Faraday's law, EMF induced in a closed coil will be equal to the rate of change of flux associated with it. So, for calculating flux we need area which is enclosed by the closed loop. Now, the question is, but as we know, when the loop is open, an EMF is produced across the ends of the loop, but in this case which area we should consider to calculate flux, because as the loop is not closed we cannot define the area of the loop. It is a wonderful question, very good question, and it needs a lot of understanding of what EMF is and how it is related to the flux and all that. See, basic Faraday's law is that if you integrate E dot dl on a closed loop, that is minus d phi dt. This is the flux of magnetic field, and as Bikas says, yes, this flux is defined only when you have a closed loop, and that is why the Faraday's law equation itself has this closed loop. You have to calculate this E dot dl on the closed loop, which you call EMF. If this electric field is a driving force, this gives the driving force, and when magnetic field changes, this flux changes, the magnetic field changes, then it creates an electric field, or if the loop itself is moving and therefore the flux is changing, then you have that Q V cross B type of motional EMF. So, this is the basic equation, and if you have an open loop, it does not apply. You cannot calculate the flux and you cannot calculate this integration. I give you a very simple example. Suppose I have a wire which goes up to here and then it is open, and here is a confined magnetic field which is changing with time. So, maybe I have a very long solenoid, so that the magnetic field is only in that cylindrical volume and not outside, and that magnetic field is changing, and because of that you can see some phenomena. Now, if I connect some circuit here, yes, I see the current. If you connect a LED and change this magnetic field, you will see that LED is glowing and all those things will happen. But if I connect the LED here, if I connect my circuit here between the same 2 points, what will happen? You will not see LED glowing, because if you consider this closed loop, in this closed loop you do not have any magnetic field, no change in magnetic field, and the flux is 0, and therefore d phi dt is 0, and you do not have any driving force, net driving force across this whole loop. So, the EMF is not generated between the ends of the coil. Between the same two ends, if I connect an LED on this side, it glows. If I connect an LED on this side, it does not glow. So, EMF comes only when you have a closed loop. Once you put your circuit, the loop is closed, and then you can calculate EMF, and from there you can calculate currents.